So in this video, there are two exercises of integrals for you to calculate, and what I'd suggest you do is you try them on pen and paper, and then I will provide you with detailed solutions in what follows. So I'd stop watching the video now and write them down. Okay, welcome back. Let's look at the answer to the first exercise here. So here's the first exercise, and we have in the integrand the sine of theta multiplied by the square of the cosine of theta. And the point to notice is that the sine of theta is up to a minus sign, the derivative of the cosine of theta. So what you could do is you could make a substitution and say that your new variable is the cosine of theta, and then if you go through that procedure you will obtain the answer. But I think it's much easier to develop the skill of just writing the answer down, so let me just do that. So what we have is the square of the cosine multiplied by the derivative of the cosine. And if we are just going to write the answer down, then what we will see is we have to write something which, if we differentiate it, whatever we write here, if we differentiate it, it must give us this. So what I think is very natural to write down is the cosine of theta, and if you wish you could write brackets all around it and say cubed, but I'm just going to put the cube sign here. And I've left some space here in front, and let's just work out in our heads what happens if we differentiate this. Well, this is cosine of theta all cubed, so when you differentiate it you'll pull a 3 in front, which we don't have here, but that's easy to fix. We'll just put a factor of 1/3 there, so that will cancel with the 3 when it's brought in front. Then you would reduce the power by 1, so you would have cosine squared, and that's perfect, that's exactly what we want. And then what the chain rule tells you to do is to multiply by the derivative of the object that was being cubed. The object that was being cubed is the cosine, and the derivative of cosine is minus times sine of theta. And here we have a sine of theta, but there is no minus sign. So again, just as we cancelled the 1/3, we can cancel the minus sign by just putting a minus sign here. And then we will add an integration constant. And it's probably a good habit just to pause and think, yes, does that work? So we differentiate it, the 3 comes in front, cancels with that. Reduce the power by 1, it gives us cosine squared. And then we multiply by the derivative of what was being cubed. And the derivative of cosine is minus times sine of theta. Minus minus is plus. So we would obtain sine of theta times cosine squared theta, the integrand. So what we see is that the integral is correct and we are happy. So I think that's much easier than going through the details of u equals cosine of theta, etc., etc. Sometimes we need to do that, but for relatively simple integrals like this one, substitution is our friend. And the key thing that we noticed here, the key structure, is that our integrand is a power of cosines times the derivative of the cosine up to a number. Okay, so here is the next integral, and we have a power of the sine function multiplied by the cosine function. Now the cosine is the derivative of the sine function, so really this problem is essentially identical to the problem on the previous slide. It's just that I've swapped sine and cosine around, and that previously we had a function squared, and now we have a function raised to the power of a half. So again, we can guess what the answer is and write it down. So let's try to do that. So what we're going to have is something like, so I'll leave a space, and it's going to be the sine function to some power, and that power is going to be an increase by 1 of this power. So this is to the half, so the power is going to be to the 3/2. So now let's see, if we differentiate that, what happens? Well, we'd bring a 3/2 factor in front. We don't have that here, so let's put a factor of the reciprocal of 3/2. In other words, let's put 2/3 in front, and that will then cancel with the 3/2 when it multiplies, and we'll just get 1, as we have here. We would then reduce the power by 1, so 3/2 minus 1 is 1/2. So that's the square root of sine theta. That's why we chose 3/2. And then the chain rule tells us to multiply by the derivative of the sine of theta, the function that was raised to the 3/2. And the derivative of sine of theta is the cosine of theta, which we have there already. So that's perfect. So this is our answer for the integral. And again, let's just pause. Think, have we got it right? So if we take this as our answer, we differentiate it, we'll bring a 3/2 in front, we'll cancel with that. We reduce the power by 1, so 3/2 minus 1 is to the 1/2, sine theta to the 1/2, that's the square root. And then we multiply by the derivative of sine of theta, and that's the cosine of theta. So if you're finding this something that you still need to practice, it may be helpful to do it in the following way. So let me just alternatively write it down as follows. I is the integral of cosine of theta times the square root of sine of theta. And I'm assuming that you're confident that that means sine of theta to the power of 1/2. And then what you can do is you can say, well, this is equal to sine of theta all to the 3/2 if you wish. And this means exactly the same as that, but perhaps it makes it a little bit easier to think about differentiating it with the chain rule. So when you differentiate this, we bring the 3/2 in front. So we need a 2/3 to cancel that. And then from the chain rule, what it tells you is that you reduce the power by 1, so you get sine of theta to the 1/2. That's that. And then you multiply by the derivative of what's in the brackets. Derivative of sine is cosine, and that's exactly that. So that would be our answer for the integral. And perhaps when you're getting used to these things, writing it in this way with brackets all to the power is helpful to make you feel more confident with using the chain rule and performing the integral by inspection. So really what we're seeing here is just the general property that if you have, let's say, the integral of the cosine of theta to the power of 1 times the sine of theta to the power n, then that integral is going to be something like sine to the n plus 1 of theta plus an integration constant, and you can convince yourself rapidly that when you differentiate this, you're going to bring a power of a factor of n plus 1 in front, which isn't here, so we need a 1 over n plus 1, and that then is going to, if you differentiate it, give you the initial integrand. You also notice, I hope, that if n is equal to minus 1, there would be a big problem. So we have to say that this is true for n does not equal minus 1. If it's equal to minus 1, you need a logarithm. So what I'm going to do on the next slide is just write down a couple of questions that you can look at in the same sort of vein. I'm not going to give you detailed solutions, but I will give you the answers so you can check that you've got them right. So here are 3 questions for you to practice what we've been looking at, and these are very much of the format that we've looked at already, and this one is as well, except that there is an argument here is 2 theta rather than theta, so you've got to be a little bit careful with the chain rule. And what I'd suggest is you pause and see that you can get them right, and I'll write the answers down in a moment. So pause a moment, write them down, try and solve them, and in a moment, then you can come back and see the answers. Okay, I'm now going to make the answers appear. And with that, I will stop this video, and I hope it's helped you.